increases the acidity level of the ocean. But as the ice is melting, you're adding fresh water mixed in with that. So whether or not the pH is actually changing dramatically is a different question. So you'd have to talk to a geochemist to find out about their predictions for how the pH of the ocean water will change. Because if the pH of the ocean water is changing, that would affect the activity levels of algae and corals. And corals have photosynthetic algae as symbionts. And so if their activity levels are changing, that will also affect photosynthesis rates globally. We do know that temperature rises in the ocean have affected the corals. But the pH effect is more, I think, more complicated because the melting of the ice dilutes the pH effect due to the increased CO2 concentration. And you're now reaching the limits of my knowledge on this. So we're going to move on. All right, so we have problems with cutting down trees, we have problems with burning of fossil fuels, deforestation, increase, these are basically the major reasons why CO2 concentration is going up on a steady increase. But that was only our first question. What's our second question? Why is there oscillation? Yes, sir, in the grade.
Well, we use heat during the winter, so the maximum is during the winter. We're using heat, and then there's also less cellular respiration. There's less plants growing during the winter.
With that, fewer plants photosynthesizing, not perspiring. So in the winter, there is less light available for photosynthesis because the days are shorter. Temperature is a lot colder. Many plants are either dead or dormant. And because it's cold, you're using more fuel for heat. So all of those contribute to higher concentration of CO2. And in the summer, you have the reverse. So you burn less fuel, and more plants are photosynthesizing. You have longer days, lots of sunlight, warmer temperatures, all conducive to higher rates of photosynthesis, which means you take out CO2 from the atmosphere, the concentration goes down. And you get the maximum at the end of the winter because all through the winter, the CO2 has been building up. And then the minimum at the end of the summer, because all through the summer CO2 has been taken out. But why is it the winter and the summer of the northern hemisphere? Because when it's summer in the north, that's winter in the south. So shouldn't they balance each other out? Yes, ma'am, and then ma'am. All right, so more landmass in the north compared to the south. Almost all of Asia, all of Europe, North America, Central America, and most of Africa are in the northern hemisphere. There's very little landmass in the southern hemisphere. And most of the forests of the world are actually in the northern hemisphere. Especially the forests that are seasonal. So the deciduous forest in North America, the taiga in Siberia, the deciduous and the boreal forest in Europe, that's all in the northern hemisphere. So the seasonal effect, and also a lot more people in the northern hemisphere. So the seasonal effect is dominated by the north. Yes? The global winds come into effect for the next question. Because why would you be able to measure this in Mauna Loa? Because Mauna Loa is in Hawaii. Yes, sir. I'm not sure what Asian winds are. I know what you mean, but
You just embarrassed it.
so let's say global winds. The global wind patterns mix the air around the globe so that you are not looking at just the local effects. If you were to measure this in New York City, you would be looking at the effects of New York City because you would be surrounded by lots of cars, lots of houses that are burning fossil fuel, lots of people. You'd be measuring the effect of New York City on the CO2 in the local area. But if you're in the middle of nowhere, in the middle of the Pacific Ocean, not near any urban centers, towards the top of a dormant volcano, so the only thing you're measuring is atmospheric CO2 concentration several hundred meters above sea level, and that's where the global wind patterns are really circulating everything. You're not looking at local conditions. You're really looking at global conditions. So this is why you see the effect of the seasonality of CO2 going up and down at the global scale at Mauna Loa.
I have saved $60.
Anybody been to Hawaii? All right, a few people, all right. Are there any seasons in Hawaii? There are seasons. They're not the seasons that you're used to. They don't have the winter, summer season that we have. They have the wet and dry season. And the thing is that the wet and dry season in Hawaii do not correspond with this maximum and minimum that you see on the graph. And that's very interesting because you might be tempted to think that, ooh, the peak here is during the dry season in Hawaii, that's when the plants are not photosynthesizing, and the valley is in the wet season in Hawaii when the plants are photosynthesizing. But they don't match. The wet and dry season in Hawaii do not match the peak and the valleys here. So they don't explain this. That's why we have to talk about, okay, what can explain this? And it has to be a global effect as opposed to a local effect. The local effect does not explain it. So far, so good? All right, so now that you can think of all of the reasons why you might be contributing to this problem, and by the way, the Asian winds, the winds coming off of Asia do bring pollution to the US, that is true. So pollution from China does reach the coast of California, and when the disaster in Fukushima happened 3 years ago, they were worried about the radioactivity emitted into the air actually reaching the US coast. And some of you may not be aware that a few months after that, there were bans on sale of certain types of fish for sushi in the US. And that was because there were radioactive traces in the meat of those fish. And the fish had swum throughout the ocean and they had reached the California coast. And so pollution from other parts of the world does reach us. The dust from the Sahara lands in the Caribbean every year. So we know that happens. All right, so what we're going to do now is take a look at how plants actually take CO2 that leads to this oscillation that you see, at least one of the reasons. But I do want to emphasize the ecological significance a little more than just, well, we care about global climate change because it affects our lives. So let me show you something that you normally don't think about, and that's an underwater forest, not a land forest. So this is a kelp forest off the coast of California, near Monterey. Anybody been to Monterey?
No.
Like 2 people? Really? All right, you people need to get out more. If you get a chance to go to Monterey, it is now a very posh and expensive area. It used to be sardine canneries. So Steinbeck wrote a book, Cannery Row. Yeah. One person has read it. All right, maybe 2 people.
Felt like right
The museum in Salinas. Yeah, so if you ever go to that part of California, in Salinas, there is a museum for Steinbeck and about his work and his life, because he spent a lot of time in that part of California. And Salinas is a short drive from Monterey. And if you go to Monterey, you can take a nice drive along the coast. It's absolutely beautiful. But you do want to, I'm not sure if you should go to the aquarium, but you can. It's one of the nicest aquaria in the US. If you get a chance to look for wildlife, you might see sea otters. And the reason that the sea otters matter, and the reason that Cannery Row was a book that was relevant when he wrote it, was because there were lots of schools of fish, and there was a lot of fishing in that area. So Monterey was a fishing and canning region. So the beach would have smelled of dead, rotting fish, and it would have been awful to visit back then, but now it's a lovely, posh area you can go visit. So the kelp forest here, these are algae. They can be 100 feet long, so these are quite tall. They have things that look like leaves, things that look like stems, and at the base they have things that look like roots. So they look like a tree. They're not roots, stems, and leaves, but they serve similar functions in the algae. And they provide habitat for the fish as well as food for the fish. So the fisheries were harvesting the fish thanks to the presence of these kelp forests off the coast of California. Now, they were also killing the otters because the otters interfered with fishing, and also they killed them for their pelt. And there's a problem when you do that, because sea otters eat sea urchins, and sea urchins eat kelp. So what happens when you kill the sea otters? Too many sea urchins. And if there are too many sea urchins, what happens to the kelp? They're eaten down to the roots, basically, or what look like the roots. And if there are no kelp forests, what happens to the fish? There are no fish. And what happens to the fishing industry? It collapses, and the economy in that part of California collapsed because they were killing off the sea otters. So these are the types of species that we refer to as keystone species. So they regulate the other species in the ecosystem. And so when you tamper with the keystone species, the whole equilibrium falls apart. So there was a ban on hunting sea otters for decades, and the sea otter population has rebounded, and so has the kelp forest. So far, so good.
Yeah.
Now everybody go read Cannery Row when you have spring break. So you have 12 days, short book. It is a short book. Steinbeck's books are usually short. It's a nice short book. Or better yet, go to California, go to Monterey. I'm sorry?
Drink a beer shake.
I can't advocate drinking. So do not do that on our behalf.
He's so juicy.
Alright, so we'll spend a little time looking at the mechanism of photosynthesis, and we are going to look at both the big question and also smaller pieces, just like we did through respiration. We're going to take a look at the details of the chemical reactions as well as the electron transport and the synthesis of the sugars. So you probably have seen this in your textbook, which is a little different than what you would have learned in high school. So when you learned in high school, CO2 plus water plus light energy would have given you what? Glucose. And we don't do that anymore. We don't say glucose, and your textbook doesn't say glucose. Why not?
They don't.
Because the first product of photosynthesis in plants is not glucose. That's why we don't say glucose here. Yes, sir. So it's actually a multiple of the CH2O. So I just wrote CH2O in here so that you would know it's some kind of a sugar, but I didn't tell you what N it will be. So it is not N6, which would give you C6H12O6. It actually is something else. All right. So we're going to spend a little more time actually looking at plant structure and how that relates to photosynthesis in terms of the function. So you know that mostly it's the leaves of the plants where photosynthesis takes place. So you have to learn a little bit of anatomy here.